Good afternoon. My name is Denis Beauchemin, and we are going to be talking about moving from RDB to Oracle, Postgres, or SQL Server while still remaining on OpenVMS. So here's the agenda for today. The questions are why would you want to move from RDB? And then we are going to talk about data storage move, how we move the entire environment over. And then we're going to discuss the applications and how to make the changes to the applications so that they can access whatever you're moving to, and some of the items that we need to consider when we're doing a migration move. So why would you want to move away from RDB that's been running your environment for many years, maybe even decades? The main reason is that you just can't find people to support or manage RDB anymore. Everyone that knows a lot about RDB or familiar with it are old, retiring, retired, and it's not going to get any better. The other aspect is that while SQL access in RDB is pretty much industry standard, nothing else within RDB is the same as anything in the industry. So this is something that is preventing a lot of things. And also there's a question of future support, especially after this morning's presentation. We find that we don't know when RDB is going to be available on x86, if ever, and whatever is going to happen after that, who knows. So that's an aspect that's critical. So the targets that we're looking at for this move is either Postgres SQL, and we suggest V16 or better, Oracle 19, and you can access that from an Oracle 19 server running on the Linux box. You can access it from OpenVMS with the existing client that on OpenVMS. So that's an option right there. And or if you want to go directly to Linux, migrate to Linux, then you can access it. You can go all the way to Oracle 21 or whatever comes after that. If you're still going to stay on OpenVMS or accessing Oracle 19, you will not be able to go beyond Oracle 19 while on OpenVMS because the client won't talk to anything newer than Oracle 19. And then you can also go to SQL Server. Let's talk about the roadmap to move away from RDB. The first aspect is going to be to replicate the data storage that you have in RDB, and you're going to have to put that into your target RDBMS. And then after that, you're going to have to migrate the access method that you're using to access RDB to fit the new database to which you're going, your target database. So if you're using SQL mods, there's one method to do that. If you're using embedded SQL in C++, there's another method to do that. That's pretty straightforward. The issues become a little more complicated when you're going to migrate the embedded SQL in Fortran, COBOL, or Pascal, because that's going to need some changes. So what we're going to be doing is we're going to remove the embedded SQL that's in your code, and we're going to create SQL mods from those things and then migrate them with a tool. If you are on Linux, if you're migrating to Linux and you're using Oracle, you can use Oracle Pro COBOL, but that's available on Linux from Oracle. So your COBOL programs won't have to change. Oracle will take care of that. The migration of the embedded SQL properly for you. You'll still need to migrate to COBOL, but the Pro COBOL will remain the same. So when we extract all the SQL mods or all the embedded SQL and transform it into SQL mods, the tool will place procedure calls directly back in line automatically, so you don't have to do anything to the code beyond that. Let's explore the steps to move the data storage from the existing RDB uh, to wherever you want to go. So what we need to do here is we need to extract the schema, which is going to be the tables, the columns, the indexes, everything that has to do with the environment, the DDL data definition language. We're going to have to extract the views, and we're also going to have to look at the triggers. Some of them may need to be rewritten because there are differences between RDB and other languages, other databases when it comes to triggers. For example, RDB supports the multiple whens, and Oracle only supports a single when, and then you'd have to rewrite the procedure a little differently. It's not very difficult. It's actually pretty straightforward, but it needs to be done, and you need to investigate that. There are no existing tools to do that for you. You have to look at it, but it's pretty straightforward. The other aspect are stored procedures. We've seen some customers with very complicated stored procedures, but most of the customers do not have stored procedures or have very little stored, very few stored procedures. But if there are some complicated ones, then you may need to rewrite them. I've always kind of figured that when somebody has a stored procedure or a trigger that's extremely complicated, that usually means that it should be um, uh, uh, should be code. It should not be. It should be application code. Should not be in the database. But then again, different strokes for different folks. And then the other aspect, that one final aspect of our DB, is that it is able to use VMS external calls to find out things about the environment. And now, if you're going to have the database on another platform, on another server, you won't be able to use those techniques. So you have to look at that. They're pretty straightforward to deal with. It's just not an issue. We've done several of these in the past, and it's easy to take care of it. But you just have to put some thinking into it and address it. So once you have the schemas pulled out from RDB, you have to look at them a little bit. May make Needs to make some changes. We have tools that will extract a schema and create the change, make the changes that are required to fit the whatever target you're going to. But you may want to go back in and do a few other things. The RDB has date formats, date ANSI, date VMS. You may want to make sure that you're using the proper one and the equivalent. They also have a tiny ints, which do not exist in any other database. Those are single byte characters. And we've even seen some customers that instead of putting in an integer value in there, 1 to 256 or 0 to 255, they actually put in characters. So you have to be careful and find out what's going on there before. And the other ones are data overloads. These are interesting. This is where RDB does not have a level, does not have data integrity checking. You can put anything you want in an X field, X256, and you just pack it in there. And you can have floating points, integers, all sorts of stuff. And COBOL is one that usually likes to use this. They will have different data definitions depending on a character in the field, or maybe another in another column on the same for the same row. That will tell you use this X256, look at it this way, or look at it some other way. So there are ways of doing that for doing that in Oracle and other ones, but you have to be aware of that beforehand, or else you're going to have some data integrity issues, and Oracle and Postgres just not going to like that. So you have to fool them a little bit. What we want to do when we're looking at dates in RDB, all dates are quad words. They just keep everything in the dates from 1858. I forget exactly what phone it was, but it's a number of milliseconds since then. And that's a big quad word that goes in there. No other database does it that way. And of course, any tools that you would want to use to go after your data in Oracle or Postgres or SQL Server would not know what to do with that date. They just wouldn't understand it, and nothing would work properly. So what we want to do is to convert all these quad word dates into normal Oracle or normal database dates, if you will, and just store that. So we're going to talk about doing that. And what we do is we just convert those quad words. We convert it to timestamp in the schemas, and then you select the one that you want. You also want to rationalize the schemas. RDB is a multi-database paradigm. We've seen applications where one program will access six, seven, or eight different databases, different RDB databases, and that simply does not work really well with Oracle or Postgres. What you Instead of having multiple databases, we're going to have one database with multiple schemas, and that way we preserve the recovery and the throughput. When you do a bunch of selects and everything, and you want to do a commit at the end, you don't have to do a multi-database commit. You can do one commit, and it'll commit for everything across the schemas inside of the database. So that's what we would do for Oracle and Postgres, etc., is to have multiple schemas defined within one database and just load everything into that database. So once you have the database schemas built in your Oracle or your Postgres environment, you're going to go ahead and extract the data from RDB with RMU. And what it's going to do is produce one data file per table that you're extracting. And there's also going to be one control file per table, which says, in effect, this is a record and this is where everything starts, the different columns, what they're located in, and what they're supposed to be. All the numbers will be extracted as ASCII, and all dates will be extracted as human readable dates. So the loading program will be able to deal with those things, will be able to read all the data that's on there. You can create scripts to do that, because you'll probably do it multiple times while you're doing a migration for testing. And you can script everything, and then it knows that to extract a table into a data file and the control file that comes with it. There may be some changes. I've not seen any, uh, but there may be some changes to the control file. You can script those as well. And then the loading just takes that and just you can script that as well and load it up. So we'll talk about that in a second. After you've extracted all your data files and control files, you go ahead and copy those across to the target system or to a place where you can load into the target system. And then if you have to adjust any of the loading parameters, what I was talking about a minute ago on the control files, you may need to do that here. Again, I've not seen many of that aspect. It's very rare, but it's there if you need it. And then after that, you just go ahead and load your data with the SQL loader or PG for Oracle, or PG loader for Postgres, or the equivalent for SQL Server. And then, of course, you can use scripts to load your data. So you can script everything from the extraction, the copying, any of the adjustment, and then the loading can all be automated very, very nicely. It just takes the time to do it. But since you're going to do it several times when you're doing testing and everything, and maybe as you get ready to cut over and do and go into production, you may have to do it again. So may as well script it and make it easy for yourself. Okay, as we were talking a little earlier, if you have multiple databases, multiple RDB databases, you just go ahead and put them into one Oracle or one PostgreSQL, and then you need to create users for the application. That's easy to do. You'll have to grant access to all the required tables to these users, depending on how your application is written. If you use one user to run your programs or to do, writes or something like that, just give them the access, the proper access, grant the access to that, to the various tables. It's easy to do. You can script that, of course. You'll also need to transfer the stored procedures that we talked about earlier and look at those as well and make any adjustments for the fact that you're now running on Oracle or on Postgres or SQL Server. And then, as we talked earlier about the external calls, if you have a system call inside of your stored procedures, and we've seen those, usually it's to find out which system they're on for some reason, or maybe the date, or no, not even the date, but just something from the system. It may not be needed anymore, so you can get rid of that, or you can retool it. In one case, what we did is we just created a little table, and we in there we said what system it was on, and we retooled the procedure to just interrogate the table. And if you needed to change the name of the system, you just changed that table, and the stored procedure just picked up the name and continued on. So just need to look at what you're doing and adapt. So RDB access in the application code is going to have to be modified to access the data on another database. And the modification or the migration is depends on the access type that you're using. So in the middle there, you see the access type. If you go to the left and you are using SQL mods right now, currently in your application, we have a tool called the SQL mod that'll transform your SQL mods to SQL PGCs or PCs. PGCs for Postgres, PCs for Oracle, and so on. So what that tool will just go through the code that's written in SQL mod. That's a very specific language for RDB, and it will transform it into embedded C and using PL/SQL as needed to do various things in there. So as SQL mod is a pretty sophisticated language, and we need to use everything that's available in SQL and PLSQL to be able to do that. One of the aspects that's very important to know about is that when it encounters the date format, the things that we talked about, like quad words on in RDB that contain the date, the these quad words they will be automatically transformed by the SQL mod not by the SQL PC that we're going to generate. It will automatically be transformed into an Oracle date when you are going to do writing. So if you're going to be storing or inserting or updating data inside of Oracle, you give it a quad word at the beginning, and that procedure will transform it into a date and store it as a date into the database. Conversely, if you're doing a select or fetch, and it's going to and it discovers that you're bringing back a date format, it is going to take the normal SQL format and transform it into the equivalent quad word, so that your application does not have to know about the date itself that has been transformed. It just continues working with the quad word, and that works either on VMS, OpenVMS, just the way it does right now, or on Linux, where you're using our other tools such as VXRT to be able to run your application. So the quad word changes are done automatically for you by these SQL PCs and PGCs, and you don't have to change your application to take care of that. And your data in Oracle and Postgres and SQL Server will contain standard SQL dates that anybody can use and report on. And then you will go ahead and take these PGCs and PCs, and we'll compile it and then link it with the application code, and everything is ready to go at that point. On the other side, if you are using embedded SQL in your code, then we're going to go ahead using our tool VX embed to mod. And we're going to extract all this SQL code, everything that's in between an exec SQL and an end exec SQL end. And we are just going to extract all that out and put it into, we're going to create an an SQL PC or an SQL PGC inside there, on its own, and we are going to have create a procedure head for it so that it contains all of the um, the data interface that you need for these procedures, and then it'll be created. The SQL PC will be created with those procedure heads, and we will put the procedure head in the source code of your application in place of the embedded SQL. And then you go ahead and pre-process and compile these PGCs and PCs, and you link them the same way you do it now as an SQL mod. The bonus on there is the fact that we are also going to do the date transformation on the fly as is required. So again, whether your application is using SQL mods or embedded SQL, and you're doing dates with the quad word that RDB uses, it will do the transformation automatically for you when you're talking to Oracle or Postgres or SQL Server. It'll change it on the fly to match whatever is needed on Oracle to make it work, and bring it back to your program as SQL mods, as not as an SQL mod, but as a quad word. The date will be as a quad word, and your application will continue using it as it always has. A very important, a critical feature of the SQL mod program is that it creates a test harness for each SQL mod that it changes, it migrates over to an SQL PC. These test harnesses will be little C programs that are self-contained. You link the C program, the compile C program, with the SQL mod, the SQL PC after it's been pre-processed by Oracle or Postgres or whatever. And then you link them. And this allows you to, when you run the program, the test program, it allows you to test all the procedures that are in the SQL mod file. And this is a great way of testing all of your procedures. And some of them can be very, very difficult to get to in a standard or normal testing environment, because you have to go through different programs and conditions and so on and so forth until you even get to that corner case. With the test harnesses, you just run the test harness, and then you say, I want, it will ask you which procedure you want to use to test. So you tell it the procedure that you want to use, and then it's going to ask you for some of the parameters that are in there that you need to give, like, user, not user, but customer number, maybe a customer address or something like that, or item number. And then the procedure will execute. And if you have any issues and it doesn't work, then you know what to debug. It's to go into the SQL mod or the SQL PC and figure out what the problem is. But most, and the vast majority of the time, it's going to work just fine. But it will allow you to test it, and then you can say, go ahead and commit it to the database or not commit it. Just it just was just a test. I just want to know if it works or not. Or you want to commit it so that you can continue on and do other testing, because there's always procedures that depend on whatever happened with the prior procedures or procedures. So you want to be able to do all that. And of course, these test harnesses can be all scripted for regression testing. So you can have all the procedures that you want to test. You give it the parameters that you need, and they can all run for you and test you. They will also give you how long it took to do whatever it is, and it will whatever it is that they were going to do, and it will also return the whatever data that is returned to you, you can actually look at it and print it out. And it tries to interpret, if it's an X field, it's going to put it out as characters. If it's a numeric, it'll try to do transformations. So you can read it. Um, and it does all that automatically. So you are able to test everything outside of the application code itself, and that way you have you can be satisfied that all your calls, all your procedures are doing everything that they're supposed to be doing exactly the way you want it to do. So this way you leave no stone unturned. You've got every full testing as you need it. So here's a diagram that a flow diagram that shows what we do for COBOL. So at the top, you've got your original PCO COBOL, which is the embedded SQL. Um, and then you've got, of course, the coblib files that go with it. And you run through this program called VX embed to mod. Okay, and it will read your code, and it's going to spit out the a cobol.cob source without any SQL in it. All the SQL will be removed. The embedded SQL will be removed. And in the same time, we are generating a PC file that contains all these SQL procedures or these embedded SQL procedures, and of course an H file that goes with it. And you can then take your COBOL code, run it through the standard COBOL compiler, create object code, the .os, and get ready for the linker. On the other side, on the right side, we'll take the generated PC file and we're going to run it through ProC or EPGC for SQL, for Postgres. And then at that point, we will have a C file expanded with the SQL calls all ready to go. Run it through the the C compiler, produce object code for that. And then the linker, you put them together and produce an executable. And at that point, your standard COBOL will be calling procedures that will access the database on another server for you. If you have Fortran, this is the flow diagram for the Fortran. Fun fact, the embed to mod was created for originally for Fortran because we discovered at one of our customer sites that they were using Fortran to access Oracle, and they went to Oracle, I believe it was 12 or 19, I forget, 12, yeah, and discovered that um, the preprocessor for Fortran no longer existed on Linux. So we came up with a method to take care of that, and which is the embed to mod, and we just created standard Fortran code as you see on the left without all the SQL calls there, and all the SQL was collected and into a PC file. And we left in the code, we had the calls to the procedures, run through the Fortran compiler, create object code, and ready for the linker. On the PC side, the .pc files, we just run them through ProC. We got SQL was expanded. The C file was expanded with the SQL it calls inside, built in, and then run through the C compiler and do that with the object code. Link them together, and you have an executable. Of course, the ProC could be ECPG for Postgres or the equivalent for SQL Server. SQL Server, yes. So it doesn't really matter. There's always a preprocessor for C that comes with these databases. It, but the one that existed for Fortran disappeared years ago, so that's why we did it this way. And we have the same flow diagram for Pascal, for OpenVMS, where we just extract the embedded SQL code from the Pascal. We just leave regular Pascal without the SQL and run it through the Pascal compiler and everything. And on the other side, we do the same thing with the generated PC files, run them through ProC, and take them all the way to the executable. ProC or ECPG for Postgres, all this on OpenVMS. Um, Pascal does not exist on Linux, so if ever you needed to migrate to Linux, you would take the Pascal that you have here that has had its embedded SQL removed, and just calling the procedures, and we have a tool that will transform your Pascal into C++ code for Linux that runs on there. But so you're not stopped if you wanted to go further. So at the end of this exercise, you're now off of RDB and you're moving on with Postgres or Oracle or SQL Server. At this point, you have a lot of people that you can find to support or manage your Postgres, your Oracle, or your SQL Server environment. It's very much an industry standard now, and you can use all manners of tools that are available off the shelf to access your data, to do graphs, to do analysis. Everything is there. There's just a plethora of tools that you can use that will work very nicely because of the fact that the data is in standard SQL format. And remember, we took care of the dates. They are now using the dates in there that are available, that are used by the industry to be able to do that. Whereas if your application is still running on OpenVMS, the dates are transformed, as I said earlier, automatically when you do an access. Your program, your COBOL program, uh, that is expecting a quad word doesn't have to worry about it. When it retrieves from Oracle, it will be a quad word that's coming in, even though in Oracle it is a standard date. And when your COBOL program writes back to Oracle, it writes a quad word, gives it to Oracle, and our procedures, the PCs will take that date and transform it to an Oracle date, and store that into the database. So your application knows nothing of Oracle dates, and your Oracle environment knows nothing of quad words, but they all work and everything is fine. Also, at this point, your future support is assured because the ecosystem for Postgres is growing by leaps and bounds. There's millions of people working with that. Same thing with Oracle and SQL Server. So at this point, you've achieved all your targets.